To begin with, we want to know how we can control anything with sound. So we can start by picking one of the most basic modules for rendering in VZX, which is renderer's basic and colored rectangle. And when we connect that to the screen like so, this is what we get. We get a white rectangle. And this has some different parameters, for instance, size, vertical and horizontal. And this is actually what we're going to exploit today. We're going to use audio to grow this horizontally once per channel. So if we look at the design, you see that there are two channels here, left and right, and we're going to make one of these per channel. So controlling this manually is fine, but how do we actually control this with audio? So let's take a look first at what we need. We have the input visualization listener module. It has a bunch of outputs. It has VU outputs, which are those that we want today, left and right. It also has octaves and spectrum data and wave data, etc. So but this one here, if we try to connect that to size, doesn't work because this is a float and this is a float 3 as a vector, x, y and z. So we need to convert this, and to do that we go into maths, converters 3 float to float 3, sounds good. Yeah. So if we start by just testing connecting that here, okay, the rectangle disappeared because the size is 0, 0 and 0. So if we again increase these values, yeah, there we are. That can stay as 0. Now if we connect the X value here, then this audio is not recording, so let's enable audio recording, visualization audio input wasabi, and then let's use the microphone device, line, let's start the recording also, 1, 2, 3. Now when I'm talking, the line is moving. So this is fine, but the line is extending from the middle. We don't want that. And how do we get to here where we have a nice design? So what I've done is, if we take this image and break it down, we find that the only part of it that is going to move is this. So I've masked out everything else with black rectangles. So this is what we want to move. And in order to do that, we can go create a white rectangle, first a black background, oh okay, let's remove the background. There we are. If we go multiply here, you see that the white rectangle in the background lights up, because anything multiplied with black is black. So the color then multiplied with black is what we want. So how do we do this in VZX? Well, first we need to export everything, and to do that I'm going to go export, and this is too high, 4000 is perhaps a better value, and then I'm going to my documents, VZX Artiste, and then 093 data, resources, and retro view meter, I call this project. And here I've already created these images, but now you know where to put them, and they are PNG images. So back to here, how do we build this? Well, we're going to use, since we have images, we're going to use blend layers, which is the same thing as the layers in here when you can select blend mode. So what we see now, the white rectangle moving, is going to be our background layer. But if we look again, this module has a render output and the screen has a render input. This one has texture input and texture output. So how do we do this? There is a module which is very useful where we can render to texture. So what we can do is essentially take this, disconnect it from the screen, and render onto here. And then we need to somehow render this texture to the screen. And if we go back to the renderer's basic, oops, I closed it. There is a texture rectangle, which is the most basic module for that. So here we go. Now, what is happening here? Well, it's rendering onto an image or a texture, and this image lives inside the video memory on the graphics card. So that memory doesn't have to travel over the bus, so that's really efficient. And here we have the blend layers module, which also works within the GPU. It doesn't do anything on the CPU, and then finally it's drawn on the GPU. So this is a very efficient way of doing this. Now let's take a closer look at the blend layers module. We have 4 layers here and a result texture size, which is currently set to viewport size, but you can set this to a number of different sizes, but let's go with viewport size, that's fine. We have, for each layer, it looks like this. You have a layer type, which is disable, solid color, and texture. We're going to use texture here, but let's just play here. If we set the solid color to red and then increase the opacity, so that's how you operate this. But instead of the solid color, we want to use the texture. So we have our base layer, and we want the first layer to be a multiply layer. That is a PNG, so let's do that. But now, if we connect it directly to the blend layer, the size of this texture is different from the size of this texture, which is 512 by 512. So we're going to pass it through one of these render surface single render to texture modules, just to get it the same size. So there we go. And now the rectangle is really large, so let's reduce that. Yeah, there we can see. Now we can see basically what we want. But this now affects both channels, and that's not really what we want, so let's go and move. That's more like it. But it's still starting in the middle, so how to do that? Let's bring the program up in full window. And actually, this is a little blurry, and that is because of the size here. So let's set to 2048 instead, like so. That's better. Now, we don't care about half of the colored rectangle, so let's move it out of way. So let's make it really thin first, just to get it into a decent starting position. That looks like the leftmost part. Let's scale it down even more. There we go. Now if we scale it up, we are getting basically what we want. So now we can connect this to audio and see. 1, 2, 3. I know for a fact that this VU values ranges from 0 to 3 or 4 or 5, and if the user multiplies the effects level in the player, it can grow very high, even 10, 20. So we need to find out how large should the value be here. So we start at 0. What is the maximum value that we want? So the maximum value seems to be somewhere around, 1.74. Now we want to use the multiplication arithmetic. So we go to Maths, Arithmetics, Binary, Mult, and we want to use 1.74. And in order to do that, we need to know that this value is a value between 0 and 1. So in order to do that, we need another module, which we can find in Maths, Limiters, Float Clamp. So what clamp does is it takes a value and it ensures that it's not lower than low and not higher than high. So let's set high to 1. Connect. Actually, let's add another mult. And now I'm going to search here, mult, multiply. So the multiplied value we connect to the clamp, and now we do that. So now if we test this, let's say the audio coming in is really, let's add this to just 1 as before. What's going on here? Right, so now if the audio is very, very high, like 3, 4, 5 as we mentioned, you have 7 here, but it's still clamped to 1. And the value here is then correctly multiplied with 1.74, which is the length of the bar that we want, so that looks fine. And this multiplication value here, currently set to 1, is to tune the visual generally. So for instance, now we can see that the audio input is sort of low, so we can increase that when I'm speaking, because I'm not making as much noise as a deep house track. But now you can see it actually peaks at red over there. Let's increase it even more. So that's one channel. Pressing Ctrl C shuts down all the controllers. Ctrl D closes all the complex parameters here. So this is one channel. How do we create another one? Well, we need to render another one of these, right? So if I hold down Ctrl and Alt and click, then I can clone a module with all its parameter values intact, mostly. So now we can move this down here, and the size is used to be controlled by this, so let's take that as well, and there we go. Let's clone this as well, and that, and that. And then we want to connect it to the right channel. But right now I'm speaking in mono, but you can see that we need to move it some more. Actually, Here we go. So now it looks nice. Now we want to add the rest of the look. How do we do that? Because we had all these small lines and left and right and dB and all this stuff, and I'm going to do that by using another layer here. So I'm going to clone this render surface single because we need to have the same size. We need to render a loaded texture, and we need to actually load the texture. So let's go screen layer. I'm already hinted there what blend mode I'm going to use. So let's connect that up to layer 2. Select texture, and then select screen, and then we're going to increase the opacity, and voila, there we are. Here it is. Now there is something wrong with this, which is it doesn't look perfectly retro, because I'm not sure if you can see it, but yeah, when I'm shutting up you can see it. It's rendering half of these LEDs. It's supposed to look like an LED VU meter. So how do we do that? Well, one way to do it is counting how many blocks there are, and there are 13. And so if we could just make the value here, which is currently a floating point value, and it's really occupying many different widths, if we can get that to occupy steps instead, that would solve the problem. So let's first disconnect this one, so we have only one to work with. What we're going to do is we're going to take this value, which we know is between 0 and 1, those are always nice to work with, and we're going to multiply that by 14. So now we have the value 14 times scaled, and then we can go and use something called floor, which means if you have 14.1 you get 14, if you have 14.51 you still get 14, if you have 14.9 you still get 14. So that's the step we're looking for. And the step is set to 1.0 here, which is exactly what we want. And then all we need to do is divide by 14, because we multiplied by 14 here. And there is a division module. So param1 divided by param2. Param1 we're going to set to 1. And then we're going to Control-Alt clone parameter value here. So now we have 1 divided by 14. And then all we need to do is multiply this with this. And that should be our new width. So let's try it. 1, 2, 3. No. It didn't work. It should work. Let's see. So that's our now our maximum value. Fourteen, 1. Okay. So what we're probably missing is the multiply. There we go. Now let's debug it and see. So the problem was that the divider was 14 instead of 13. And now it's correct. and we get these steps. So when connecting it to, now it's using whole blocks. And let's save this. Retro view tutorial. Okay. And let's just close those. Now we added quite a bit more modules up here compared to below here. And all this math is complicated, and manually dragging isn't very nice, so we don't want that. Instead, I press Alt and double click to create a macro, which I can open and close, also with Alt plus right click. And now I can control drag select all these modules, and then I hold Control and Shift to drag them into the macro. So now they are encapsulated inside the macro. And since you can clone modules, you can also clone macros. So let's clone the macro, connect it to the right channel, connect it to the size, and hook it up, and there we go. We have 2 working VU meters. So now all that is left is to do some post-processing, which is to add some glow. I'm now going to do that. And that is easy because we have everything as a texture. What we need to do is we need to go into texture, effects, and blur. As you can see, the blur module takes texture as input. And if we were to render that instead, it would look like this. And now it looks like crap because the resolution of the texture size is very small. But it's usually a good idea to set this to something connected to the viewport size. For instance, viewport size is fine, or viewport size divided by 2, or divided by 4. And the reason for this is that divided by 4 makes it a much smaller toll on the GPU to do the blurring. But right now it's not really doing much, so let's increase the blur factor here. 5 is the most nice looking one. And we're going to do 2 passes. Now it's starting to look like something. We can actually decrease the blur factor somewhat. And now we're going to use this blends with all the blend modes, but for just adding 2 color layers together, which we want to do to get a bloom or a glow, we're going to use another textured rectangle, and we're going to use OpenGL modifiers blend mode, which is not really easy to understand what these mean, but source alpha and 1 is what we're looking for. I only use that, or I play with these sometimes and get some random funny effects, but it's not really as intuitive as this, where you have all these different blend modes that it's easier to understand what they do. But we want to render then the texture without blur and the one with blur, and we're going to prepend them with this, so that both are affected by the... There we go. Now we have a glowy LED thing, and we can tweak the values somewhat. We can go into color and global alpha, and if we reduce that to say 0.5, the glow is less apparent. And if we want, for instance, a dreamy effect, we can reduce this to almost nothing, and then go in and increase. So now we have a really dreamy, dream-like, bloomy effect. That this is how you can tweak these. So there you have it, the retro LED VU meter. and when you hook this to music you will not see the same value in L and R as you do right now. So hope you enjoyed. Take care.